Good evening, all. Actually, I thank Professor Sandeep Kumar Saha for giving me a time to present my small thoughts on green hydrogen as well as fuel cells. Now Satpute sir spoke very nicely about biodiesel, ethanol, biogas, and he also dwelt on hydrogen. So just I'll talk about green hydrogen actually. Now we are having a lot of carbonization, and the world is thinking of decarbonizing the entire atmosphere as the CO2 has reached almost 400 plus ppm in the atmosphere level. So these are very alarming. And the option left is green hydrogen. Hydrogen basically because hydrogen has no CO2 emissions, and green hydrogen because it uses renewable energy for production of hydrogen. So first I will be dealing with green hydrogen, then I will speak something about fuel cells. So these are the topics what I want to deal, like global players, the status, GHG emissions globally, energy transition in India, as well as production of green hydrogen, then hydrogen in IC engines, etc. So the green hydrogen means when we use renewable energies to produce hydrogen out of water through electrolysis, we call it as green hydrogen. So that is gaining a lot of importance, and the major sectors basically it is not for small applications like bikes or cars, but as of today it is being planned for chemical industry, cement, refining, iron and steel, as well as transportation, big engines like ships and trains, and even buses are there flying now on green hydrogen. As sir was telling, we have a green hydrogen policy. India also has a green hydrogen policy, and I think we are spending almost 10,000 crores we are reserved towards that. And a lot of IITs, IIT Jammu, IIT Madras, they are working on green hydrogen. These are the various types of hydrogen. Like grey hydrogen is produced using fuels, fossil fuels. And then there is something called blue hydrogen and green hydrogen, which exclusively uses only renewable energy or the excess energy of even nuclear power plants that can also be used. So there are a lot of global players like ITM, Nel Hydrogen, Plug Power, Thyssen Cup. Then global giants like Shell, BP, Total Energy, Saudi Aramco. In India, Ambani, Indian Oil, they are also going into this Adani. They are going for this. And I think in a few years from now, as we are discussing, the petrol price today is almost 100 rupees per liter. Hydrogen will also be costing 100 rupees per kg in few years time. As of now, I think it is around 300 rupees plus, but it will be reduced with the passage of time. So these are global status, and these are the application like steel making, ammonia, heavy transport, energy storage, because these consume a lot of electricity basically. As of today, it is costly, but it is going to come down. Almost to produce 1 kg of hydrogen, uses almost 50 units of electricity. So if the electricity is even priced 2 rupees per unit, so it is almost 100 rupees for the electricity. Water is almost free, and even this water, people planning for this desalination of seawater and producing it. So India has got a national hydrogen mission, and 20,000 crore rupees has been set aside. So these are global emissions actually. Globally, if you look at energy constitutes to 76% uh, of this emissions, greenhouse gas emissions, and these are the various countries and their contributions towards coal, oil, as well as natural gas. So energy is one of the sector which consumes a lot of fossil fuels and produces a lot of CO2 emissions. And if you look at the global map, you can see there are countries like developed countries, especially. You can see America, Australia, uh, parts of Europe, China, Russia, and all. They are lot of their performance is very low when compared to other countries. And this levelized cost of hydrogen also, you can see different countries. Actually, now it is a global mission. Every country, every other country is planning to prepare hydrogen, and especially through this renewable routes. And the price varies actually. So you can see the red is 1.4 US, 1.5 US dollars, whereas blue is 4 US dollars. So the various countries are working, and this is the levelized cost of hydrogen. So these are the various projects globally. If you look at how you can see right from North America, South America, even Africa, Europe, a full lot of projects going on. India, China, Middle East, as well as Australia. Lot of projects going on like early stage. This is CCS is carbon utilization and storage basically. Then basic hydrogen, green hydrogen is made by electrolysis of water, and these are the various color coding given for the projects, and these are the capacity of these plants. So India is going through this energy transformation, and Niti Aayog is heading this production of green hydrogen basically. You can see electricity generation 33%, industry also chemical, cement, iron and steel, other industries, and transport basically. So you can see this road, shipping and all, as well as this chemical industry. They can be using green hydrogen in near future actually. So this proton exchange membrane, that is a very promising technology, and I think railway has already started that in India. I'll come to that in my next slide presentation. Basically, these are the economic trade-offs: carbon emissions, air pollution. And there are a lot of now people are going for ESG, environment, social, and governance. All companies are supposed to adhere to that, and keeping that in mind, green hydrogen will be the main source of power in years to follow. Uh, there are a lot of collaborations across borders are happening for between countries. Basically, electrolyzer as a technology, India is still importing, and that is a very expensive first cost basically. This is already used in chloralkali plants, which are seen in Karwar, Karnataka, where they produce chloralkali. So these are the regulatory frameworks. Uh, And hydrogen can be used in two ways. Either it can be directly burnt in an IC engine, or else it can be used in a vehicle to produce electricity through fuel cell, and then that fuel cell electricity, whatever is produced, will drive the vehicle. That is electrical vehicle basically. So there are problems, challenges of storage and onboard storage, as well as the infrastructure that are being a lot of research is being done in various IITs. In IIT Bombay, we have seen that fiber reinforced plastic containers. So this was about hydrogen. Let's go there. Now I will be speaking on fuel cells basically. I think, sir, my presentation is visible.
If you can trace, then you can see something is like it is now. It's a green color screen is coming.
It is showing it is my.
You go to the maybe next slide. Maybe something will come. Are you able to see anybody like?
Anybody?
No, no, only green color slide as you say. A blank slide is there. A blank slide is there. Of
Okay,
screen
I'll
share.
start. I'll start once again. I'll start once again. Touch screen. Now, sir.
Okay, now we are with you.
Okay. So now we look into fuel cells actually. So fuel cells, I think that is a very promising technology, and a lot of research has been done, and already cars, trucks, as well as buses are flying actually by various leading manufacturers in the world. Uh, and that also basically, as we have discussed, transport sector accounts to almost 23% of the global CO2 emissions as per International Energy Agency 2023 report. And this is very heavy duty burden basically, and that is why the decarbonization of transport sector also is a challenge. So the present technology IC engines, they use uh, fossil fuels, be it petrol, diesel, and they contain carbon as well as hydrogen, and that is why a lot of CO2 emissions are happening. Fuel cell is a technology where the direct energy conversion takes place. The fuel hydrogen, it is like a battery basically, where you supply hydrogen, and then you all you get is water as the tailpipe emission. So it is basically zero efficiency, zero emissions, and has got very superior efficiency, almost 2 to 3 times that of gasoline engines. So hydrogen gas is fed at the anode. As I was talking about battery, battery has got anode as well as cathode, and oxygen is supplied from the air to the cathode. There is a catalytic reaction. These catalytic reactions, again, lot of noble metals are used, and that is why this technology is also expensive to begin with. Catalyst splits the hydrogen into protons and electrons at the anode surface. Then there is ion migration. Protons pass through the electrolyte membrane. Electrons flow through the external circuit generating electricity. And at cathode, the protons, electrons, and oxygen combine to form water as well as heat. So you can see, as I spoke, you can see the cathode, anode, as well as electrolyte. So battery also has these three components. So the anode, cathode, electrolyte member, and the catalyst. Catalyst is something which doesn't participate in the reaction but accelerates the chemical reactions. So proton exchange membrane, PEMFC, FC stands for fuel cell. They work at normal temperatures basically, whereas other thing they work at high temperatures. And we have got something like alkaline fuel cells, AFC, as well as solid oxide, as well as phosphoric acid fuel cells. So you have a stack, like a battery is composed of various cells. Here also fuel cell you have a stack, and then there is a whatever electricity is produced is stored in a battery, and there is a electrical propulsion, and you have almost 300 to 400 miles, and almost 500 to 550 kilometers per tank of and refueling. The challenges faced by electrical vehicle of fuel means range anxiety and refueling time, they are addressed through this, because it fueling time is only less than 5 minutes. So this is about the technology. And coming to applications, Toyota Mirai, actually more than 1 decade past, Toyota Mirai has come out with this hydrogen car, as well as had Hyundai Nexo. Then heavy duty trucks are there by Hyundai and Toyota, and material handling for forklifts also have these engines, as well as rail locomotives are being, and even marine engines are heavy duty engines, so those are can be powered through hydrogen. Just I had taken a screenshot. Indian Railways is the very latest one. Indian Railways this year only is going to launch this hydrogen power train. Our Honorable Railway Minister, Mr. Ashwini Vaishnav, he has shared it on Twitter actually, basically. And India is one of the few nations, the fifth nation globally, which is going to deploy trains with hydrogen technology. BHEL, I had an opportunity to visit an exhibition in Bangalore where I've seen BHEL has also come out with a fuel cell bus basically. But they are tied up with Singapore based Origin Fuel Cell Technologies to develop and manufacture fuel cell powered rolling stock for the Indian rail market. It is not currently manufacturing, but Ashok Leyland and Tata, these are two leading manufacturers of buses. They are doing, and the pilot project is there in Leh basically. NTPC also is interested in that and playing a role. So in this Indian Railways, even integral coach factory where they manufacture coaches, they are planning this hydrogen power train coach in Chennai. And the first 1200 HP train, this is like small train, 6 car or 9 car train that will be manufactured, which will be using hydrogen. Then hydrogen trains are being planned. So this is like DMA, diesel electrical multiple unit track using fuel cells. So this has quite operation, zero tailpipe emissions, and the scale can be flexible basically. So the challenges are in hydrogen production. As I was telling, 50 units of electricity to produce 1 kg of hydrogen is very challenging, and that is itself is a very expensive recurring cost basically. Then storage, 5,000 to 10,000 psi pounds per square inch. Storing that is very challenging basically. That their options are. If you look at the LPG tank cylinders earlier, we had a big cylinders, but when you see it CNG being transported, we see that small cylinders are multiple small cylinders are mounted on the trucks. Similarly, this hydrogen also, the technology is being developed. So cost reduction, as I was telling, the precious metals are costly. So the cost of durability also a challenge, and commercialization as of today is yet to pick up. So we have got the 17 sustainable development goals. So all the countries are planning to reduce or decarbonize their transport also. So European Union also has got a target of zero emissions of vehicles by 2035. So they are pushing EVs as well as hydrogen. So cities are basically facing problems with emissions basically, and this fuel cell technology is very promising. Uh, these are the three technologies which are proven as of today. Commercial also they are manufacturing, be it proton exchange fuel cell or alkaline fuel cells or solid oxide fuel cells. So these are the various applications, and the benefits of over the conventional vehicles is IC engines is tailpipe, zero tailpipe emissions, like NOx, no NOx, SOx, anything like that. Performance is very good because it will be electrical vehicle, so its performance is too good. Then quiet operations, there is no noise, no moving parts much, and it is scalable right from bus engine to even locomotives. So production is a challenge, and green hydrogen using solar or wind power is being looked into. So these are all the things uh, various governments are planning. Even private industries are like Adani, Ambani. They are also playing a role because hydrogen in due course of time will be the fuel of the future. So this is the target 2035 European Union zero emission target, 2040 heavy duty transition, and uh, fuel cells complement electrical EVs perfectly for long range as well as heavy load applications. So these are the few references basically, and thank you, sir. Any questions?
Yeah, very informative
No, no,
presentation.
no, sir. Thank you, and I really thank you for the opportunity. And I thought,
No, no, very nice. So if nobody wants like tomorrow, then like others has to present. Okay.
yes, sir.
So then today I am closing.
Okay.
Tomorrow we'll discuss a little bit more, and I will start from 7 o'clock. Okay.
Oh, okay, sir. Okay.
Okay, sir. So then I'm closing it today.
Thank you, sir. Thank you.
Thanks.